Thank you, Lance. I appreciate the opportunity to be here to speak to everybody. Brief introduction to knowledge graphs, how we're using them at NASA, how I'm using them within the People Analytics branch of human capital across the agency, particularly how we're combining knowledge graphs and algorithms to find hidden skills. Hopefully you'll find this entertaining and informative, and look forward to the questions at the end. So let's go ahead and get started. So first off, why are we doing this? Why are we even looking at this, and why are we trying to look at this data set? Well, various research and surveys have gone out looking at individual skills or industries and how we're doing things. One of the things that are keeping HR leaders and CEOs in particular also are very concerned about this is building critical skills and competencies. What we've noticed over the last year during these unprecedented times is that we really need to relook at how we're looking at our skills. We may have to retool our individuals, especially as we're trying to find new ways of doing hybrid type work, remote work, telework. All of that is bringing across a transformation in looking at how we look at our skills and identifying the knowledge that's out there within our organizations. So that started me in the journey of looking at how can I use knowledge graphs to be able to really combine the data we have around our peoples, our occupations, and our training to truly identify what we have in our organization, what's lacking, and really look at how we can utilize some of this. So first off, what's a knowledge graph? You can talk to many people and you're going to find different definitions. The way I look at it when I think about knowledge graphs, especially for an enterprise, it's a mechanism or it's a way to connect different data sources together via some type of common relationships, and it can bring together both structured and unstructured data. The beauty that I like about knowledge graph, especially when you utilize graph databases behind it, is that within a graph database, unlike some of your traditional relational database management systems, is that you can add data very easily in and out of the data. You can create relationships, remove relationships without really causing a whole lot of headache around your data model or your schema, because they're built to be easily change things around. And you can really start to identify different clusters, find latent connections that may be in your organization, but it provides a good way to identify this information, looking at it both from a graph perspective, utilizing graph algorithms, but then it also allows you to look at it in the more traditional ways through tables and lists, and put those in any kind of visualization tools that you may have out there. In order to do this, you only need a few little things besides the graph database. You've got some different algorithms you can look at. We use various types of text annotation within our data sets in order to identify skills within employees. When we start thinking about how we're going to identify the structure of the network, we're looking at pathfinding, centrality, community detection, some of the built-in graph algorithms that are available within the graph data science libraries. We've also taken some of that data out to look at text rank, similarity, maybe even some sentiment analysis, and utilizing that information and ingesting it back into the graph the graph database in order to enrich that knowledge graph and provide more information to us. So how do we create it? Well, I use Neo4j, of course, and the graph algorithms that are in there. In particular, I'm going to show how we use node similarity. We're also evaluating some of the graph neural nets that are starting coming out. Sage within Neo4j is one of them, but I'm also looking how we pull out the information and utilize graph neural nets outside of that, maybe in AWS or GCP. A very simple or common programming language, Python and R, to do some of the text similarity using Doc2Vec, entity extraction, or even using BERT, RNN, and Spacy. All those things are capable to be used in your workflow, in your pipeline for building your knowledge graphs utilizing the Neo4j graph database. So how did I do it? And I'm going to go over a very high level type of introduction of building this knowledge graph and what I did, then kind of go down into a little bit into some of the low-level data model itself real quickly, and then show you some of the outputs that we get from that. But from a knowledge graph model workflow, it's very easy to start off. We start off with the occupations. And the occupations inside of that have information about that occupation that's ingested into the knowledge graph. That information could be what type of knowledge is necessary for that occupation or work role, what skills are necessary, abilities, tasks, and training. So that's where the acronym KSAT, knowledge, skills, abilities, tasks, and technologies comes from, to where we get that information and we build a vocabulary about those occupations and feed that into a Doc2Vec model. Additionally, the information of those elements or those case sets of the occupation have different assessment values, their importance, the level required, how many years. All of that information is built into it via an existing database called Onnet, which is from the Department of Labor, that we've been able to use as our foundation for our taxonomy, as well as our information we're using within our graph database. So once we've built that graph model and looked at, once we built that vocabulary and created that Dr. Beck model, we can use that model to infer against an employee's information. So their job description, their performance evaluation, their resume. We can look at each of those sentences within that information, infer that against the Dr. Beck model to see how closely they may be related to one of the elements that's associated in the vocabulary of the occupation. That allows us to relate that person to those case sets. Now I have the occupation to the case set, so now I can start doing a lot of things by putting it into a graph database, run some graph data science capabilities, and take a look at skills gaps, career paths, succession planning, and even looking at how we're strategically aligning our workforce across the organization. So let's start off. How does this all begin? Knowledge graphs are very simple and very easy once you break it down into the basics. I've got 3 different data sources here. I've got an occupation, I've got training, and I've got employee. All of those themselves could have their own data source and information there. But when you combine them together, you're starting to build a knowledge graph across those 3 to see how they're related. So when we think about it, we started with this Onnet Occupation, and we took a look at this from the occupation side. That's going to be our foundation, as I stated a second ago, and it has all these different occupations, these different elements. So what is it about these occupations and elements that I can use to relate back to training or back to an employee? So as we break that down, we really came down to those case sets. And I can really break that down even further. It comes down to 3 different things: knowledge, skills, and tasks. Every occupation, you need a piece of knowledge to do that work. You have to be able to have some type of skill, and you have to be able to do some type of task. So for example, I have knowledge on natural language processing. As I've shown in some of these work we're doing with the Dr. Beck models and things, I have the skill of being able to do text similarity within natural language processing by comparing 2 different documents to see how similar they are to each other. And I've done the task of running the Dr. Beck model in order to be able to come up with those similarities and those relationships. Well, that can be related back to an employee. Since I have this knowledge, skills, and tasks, and the occupation requires those knowledge, skills, and tasks, then I can combine those 2 together to find out how closely related I am to that occupation. Similarly, training has those same types of information there. If you take a class in natural language processing, you're learning knowledge on that. Within that, there may be a section on text similarity, which is a skill you're looking for. And within that section, you're going to do exercises on running a Dr. Beck model, which gives you an information or an idea how to run that task, and you're starting to learn how to do that task. So now I've combined occupation to employee and training all together through that connection of knowledge, skills, and tasks around this. So that's the development and the genesis of how we develop the knowledge graph, and then from there it just explodes wildly. Because of that, we can start adding other things. Having that information, now I can create a job profile and an employee profile based on all those case sets, and really start seeing how we compare a job profile to an employee profile. And within our own internal talent marketplace, now an employee can start beginning to search for job profiles that meet their skills, or a supervisor can look for employees that may match the skills they need to do their project. So we're starting to be able to do recommendations, looking at things like that, of both jobs and skills, or recommend training you may need to take in order to enhance your skills. And that's going even further. We're starting to look at how we can recommend mentors. We can do expert finding people with specific certifications or licensures. Many, many things you can start adding to this very easily through the knowledge graph. So once we do that, we can also add the information about the employee into the database. So the PDW is our personal data warehouse. The talent marketplace is where we store the information about the employee and the jobs, and then we have a job evaluation tool. So we're now adding more data to further enrich our knowledge graph, and the process just continues and continues to grow your knowledge graph. So with that, we can then add who the employee charges to. They charge to a particular cost center. That cost center is in a project. That project's in a program, mission, and theme, etc. So now I know what employees are in what organization, and then I can start answering questions for the organization, such as what skills are within my cost center or my project. What skills am I missing based on the work roles that I have? What skills am I losing due to attrition? Those are some simple questions that we can start answering based on this knowledge graph that's being developed. So don't want to scare you with this picture here, but this is using a recent release of the Cypher Workbench, where I was able to kind of reverse engineer the model, connecting it to my graph database, pulling out the model and showing you the data model that's built into that. And I'll go a little bit lower level and just kind of give you an explanation, but it's got all the different elements within it, the employee, the occupation, the KSAT elements, training that's involved in there. All of that's connected together, kind of gives you an idea of all the work that's going on behind the knowledge graph. So taking a look really quickly here at the employee. So now you can see the employee has various nodes connected to it, ethnicity, grade, the center they worked at, how long they worked at, gender, and who they charged to. Those are the ways that we're able to connect back and forth and to see how we can answer information about various employee type of characteristics, as well as the skill sets around the different places they're charging to. Again, the employees are also connected to various occupations. As I mentioned earlier, we started with the Onnet Department of Labor database of these occupations, but we have some very other specific occupations that we need to look at. Within the government, there's an OPM classification for job series, but NASA also has their own NASA class code. Those have all been crosswalked around, so now we can get more specific information on NASA specific jobs and what group they are and what skill mix we're looking for. All of this information is added into the knowledge graph, and it just keeps growing and growing and provides us more rich information. All right, so that's a little bit about knowledge graphs. Again, very high level. I know I went through that very quickly, but as you start playing around with models, you'll see how those things can develop. So let's talk a little bit about graph data science. So graph data science it's really starting to come more and more in the last several years. This image here is courtesy of Dr. Alicia Frame of Neo4j and her and her team's great work on graph data science, kind of showing you where it fits into the entire ecosystem within the graph universe here. And kind of in the middle, utilizing the different types of techniques they develop to answer insights and get predictions on your data. I'm not going to dive a whole lot into this. I'll let somebody smarter than me, like Dr. Frame, talk about that. But I'm going to show you a little bit of how we utilize at least one of the couple of the algorithms there in order to get some of our answers. So in this particular case, this algorithm, we use node similarity. And again, here we're just looking at how the nodes are connected together, the intersection of the nodes is similar between two nodes, and over the union of all of that. It kind of gives you a Descartes similarity score, telling you how closely they are related to it. So in order to run this algorithm within Neo4j, you first have to do a projection of the data you're looking for. So that's what that first line of code in green. I'm using the graph data science library to create a Cypher projection of the graph I'm looking for. And here I'm pulling out all occupations that are tied to a particular OPM classification. And here you're seeing the GS 2210, GS 0340, GS 0343, all of those are related around IT occupations and how they may compare to a management analyst. This particular algorithm was used kind of for a career change. If I'm a management analyst, but I wanted to go more into an IT field, what jobs out there am I closely related to that I could do, and what would I need to learn in order to upskill myself? The second part of the code here is to stream the results back to the browser. In this case, we pulled it back out and put it into a table. But if it tells you, I want to compare the management analyst to all other occupations. The result set looks something like this. On the left-hand side, you're going to see the graph. Everything in red there are the actual occupations, and everything in pink there are the different skills in this particular case that are the different elements, that are similar within those various occupations. You can see right in the center there's a whole cluster that are common to all of them, and then some of them are unique to other occupations. So if I'm a management analyst and I'm looking to change careers and I want to kind of go into IT or some kind of business intelligence or something like that, what are my options? Well, It looks here, a management analyst is 72% similar to an information technology project manager, business community planners. I mean, there's a whole wide range of jobs within Onnet that show this. So there's a lot of different things you can look at. Information security analyst. It tells you how closely you're similar you are. But from that, we can also pull out what's necessary for you to upskill in order for you to get to that occupation that you're looking for. Just an example of how we use node similarity to try to find alternatives for somebody if they want to change careers or find a different type of job. We can also do things within this discovering connections. And I'm going to go back and forth showing tables and graphs just because of the beauty of being able to do both within Neo4j. Or in any kind of graph, but in this particular case, we're looking at our cost center. In this case, we have an earth science cost center where we're charging to, and we wanted to look at who's charged to it and then what work roles are in that. We used this in a scenario where a recruiter came to me and asked if we could pull out all the different work roles within the earth science theme, because they were getting ready to go to recruitment fair during Earth Day back in April, May, I forget now, and they wanted to see what jobs are related there. But then we could also tell, who's there, and if I know who's there, then I know what kind of skills they have. So if I can start aggregating what are the skills related to an occupation, to a project, and so forth, and really answer a lot of the deep questions that some of these managers are asking. One of the other things we've been starting to do under this current administration, we've got a lot of interest in diversity, equity, and inclusion initiatives. We're starting to look a lot into our organization and how we're broken out as far as diversity. Are we equitable in how we're providing our training, our promotions? Are we equitable in who gets what opportunities? Are we including the right individuals within different types of classifications here? This is a simple little chart showing you the breakout of gender across this particular charge code. As you can see right now, it's highly proportional male to female, a higher male. This is just a rough sample, so a sampling of that is not everything, but kind of showing how you can break that out. All of this can be aggregated into a table and do some different analysis to see what the breakup is and are we being diverse as compared to either industry or other organizations or what it is that our metrics are at that time that we're looking for. So let me go back now to a little bit of a table view that you can always pull out of Neo4j utilizing many of the protocols. In this case, I'm going to rank skills by occupation. I want to find out what are the most important skills for a particular occupation. In this area, these are just the basic skills. So here again, we're looking at everything within an IT type of relation: 2210, 1550, 854, and 855. Our OPM our levels, our job classification. In this case, the 1550 is a computer and information research scientist. And because we've got some assessments within the Onnet database that tells us how important this basic skill is to this work role, I can then start bringing those out based on that level and then order it in descending value. So the top most important basic skill for a computer and information research scientist, understanding written sentences and paragraphs in work-related documents, much higher than using mathematics to solve problems. So it shows here how communication is even more important than being able to do the math in many cases as a basic skill in this particular job. And I would argue that in most jobs, you need to have the ability to do this kind of communication. So it kind of gives us an idea there of how we can do that, which opens up the doors for us to be able to use that metric or that value as a weight in many of our algorithms and our models. Another thing we've got here, as we look at as how we're trying to look at employees across their abilities, this case here, we're using that same node similarity where we compare one occupation to another, but we're comparing an employee to an occupation. How similar are employees to this occupation? If I'm looking for somebody that meets certain requirements, I can use this algorithm and this method and methodology to find those employees that are highly similar to this particular work role that I'm looking for. As we start fine-tuning our work roles through all the additional information we put in there for NASA-specific classifications, we'll be able to be a lot easier for us to find the people that really match our goal, or at least understand where we're missing our goals and are missing our skills and that we need to increase upon. So there's other ways we can utilize that. So I've talked a lot already, and hopefully I'm sticking the landing, with this final page here. I've shown you a lot about how you can use knowledge graphs, how to create them, some of the things about data science, graph data science, and some of the outputs you can do. There's a lot of questions within the people analytics and human capital that I think can be answered with graph databases and graph analytics. I think it's a growing field, and I look forward to seeing what we all can do with these types of technologies in the people analytics realm. So thank you, I appreciate your time, and I'll open it up to questions.
Great, thanks so much, David. And yes, you did stick the landing. I love that slide. So I want to remind the audience that they can submit questions by typing them into the questions tab located at the top of their screen. And if by chance we don't get to your question, someone from Neo4j will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. But some have come in while you were presenting, so we can go ahead and get started with those. So this one is asking, are you limited to using algorithms only within graph data science in Neo4j?
Good question. Yeah, definitely. No, the simple answer to that is no, you're not limited to just using the graph data science library. The capabilities within Neo4j, of course, have grown a lot using graph algorithms over the last several years, and I expect them to grow even more. But like any other database, you can pull information out of the database and utilize your own analysis. Quick example I guess I can share here. Several years ago, when I first started working with graph databases, I created a lessons learned graph database that had documents inside of the graph database. Each of the nodes was a lesson, and there was information about that lesson, the lesson itself within that stored in the database. I pulled out the data, the text of that lesson, of all the lessons utilizing Python, pulled it out, created did some topic modeling on top of that to identify the different topics within all of those lessons. I then utilized the results of that, what topic they were in, their value, their theta value of that, the different keywords that were associated to those topics. I ingested that back into the graph database and made those connections. So now that added a node of that I've had this lesson, but I know what topic it's in, and because that's related to other lessons, then I can pull up lessons a lot quicker based on their topics, or I can pull it up based on keywords that I may be looking for. So it adds a lot of information. So while the graph data science library is really growing, there's a lot of potential, a lot of use there, you still can do your traditional analytics utilizing graph database in whatever format you're doing, whether it's Python, R, Java, TensorFlow, AWS, GCP, but you can still ingest that into your pipeline. The graph database has become another tool within your pipeline and in your analysis workflow.
Great, thank you. I love that example too. It's awesome. And so here's another one. How do I get management to buy into knowledge graphs?
Oh, that is an excellent question. I get that a lot, actually, quite often. Again, I've been working with these graph databases for close to 10 years now. The term knowledge graph is fairly new in industry. I mean, Google's been using the term knowledge graph for quite a while. But the concept of knowledge graphs and using graph databases, knowledge graphs is fairly new. What I found for me over the years is really lead by example. I find an issue, a problem, a question with some high visibility within the organization, somebody that's really having an issue trying to find the answers that they're looking for. See if it's, first of all, if it's a graph problem, and if it's a graph problem, great, and then you can really start utilizing graph technology and graph databases within that. Build a prototype, build a solution, show how that works, and then advocate. Most of the time when I would do that, I would develop a solution, get a platform, and it might have been a small one, but it was of high importance. I then would do a little write-up and post it out there within our internal communication. Inevitably, I would get within the first 5 minutes at least 10 phone calls of people asking me, how did you do that? Can you show us? Can you help us? That's part of the buy-in there, but then also showing the value of the speed and the quickness of finding some of these information. Recently, I had well, going back to that recruitment, where they wanted me to find out all the jobs within a particular earth sciences. In the past, utilizing our traditional data connections and data sources, that would have taken me a couple of days of pulling the data out, downloading it, running some analysis and munging and getting to the proper format to be able to showcase. It would have taken me 1 to 2 days to give them that answer back. It took me 5 minutes to write a query within the database and pull that information out. So showing the value that you can speed your process up, that always helps to show management the importance of knowledge graphs and graph databases.
Great, great. That's excellent advice. And I know we're running short on time, but I want to get this last question in here. It says, it looks like you've been using knowledge graphs for a long time. So what do you think are some of the benefits of using knowledge graphs?
Yeah, I think I've been using knowledge graphs before knowledge graphs were cool. But some of the benefits, I think, first off, is the ability to connect different data sources together easily. I'm not saying you can't do that in other types of databases. I find it a little easier to connect them within knowledge graphs due to the ability to create relationships across those things. Easier relationships than you can across some of these other relational database management systems. And granted, I mean, full disclosure, many years ago, I'm not going to say how long ago, I started my career as a SQL developer and database administrator. So I've had the pleasure of writing various joins and queries along that. So I understand the differences in that. But I find it a lot easier within graph databases. So that's some of the benefits there. The other benefits is that it makes it your ability to find clusters and different patterns a lot easier and visualize those patterns a lot easier within a knowledge graph as you're running through some of your methodologies for algorithms or visualization. And I guess thirdly, it's just it's an easier, in many mindsets, it's an easier way of visualizing the data. A lot of us are very visual in how we see things, and if we can show that visualization a little easier through some type of graph visualization, it provides a lot of benefit to the end user. They don't have to try to look through a table all the time to try to figure out where the connections are. They can visually see it. So all of that gives us an opportunity to really show the benefits of how knowledge graphs can be used. But bottom line, I think it's just a matter of the fact that we're finding information a little bit faster and making connections that we didn't see before a lot easier. So hopefully I've answered those questions. I really appreciate everyone's time, and feel free to reach out on any of those connections there. I've also got one of my interns that supported me in this endeavor, and feel free to reach out to us if you have any questions.
Great. Thank you so much, David. It is always a pleasure to have you on with us. So I really appreciate your time and being with us here today.
Thank you. I appreciate the opportunity to speak to you guys again.
All right. For those in our audience, the next session will be starting in just a few minutes, so stay tuned for that. Thanks so much.
Thank you.